Very good. Very good. The first equation of motion, it stated that V equals to U plus AT. So as per we have your kinetic equations of motion, or we can just write it as equations of motion. We can write it as equations of motion. And under the equations of motion, we have three equations of motion. So I told you that you have the first equation, and the first equation of motion, it states that V equals to U plus AT. So you have here V equals to U plus AT as the first equation of motion.
Good evening.
See, there is no displacement. Nothing as displacement is there in this first equation of motion. Then we did the second equation of motion. In the second equation of motion,
S is equals to ut plus 1 by 2 at square.
yeah, we had S is
S
equal
is
to
equals to ut plus half at square.
ut plus half AT squared. So S is the displacement, U is the initial velocity, T is time, A is acceleration. So in this equation, you do not find anywhere, you do not find V. There is no final velocity term in this expression. But if you can use this equation to find out the displacement. Okay. Today we'll also do the third equation of motion. There are these three equations of motion. So the third equation of motion, it states V squared minus U squared equals to AS. So you can either remember it this way, V squared minus U squared equals to AS, or you can also write the same equation as V squared equals U squared plus 2AS. Hello?
Sir, how do
Sir,
we write the third
अब बेटा मैं
equation?
क्लास ले रहा हूँ हाँ मैं क्लास ले रहा हूँ बेटा
sir, here S is in the equations of motion. S is displacement, sir.
Yeah, S is the displacement. S is the displacement, V is the final velocity, U is the initial velocity. So as we had derived the first and second equations of motion, we will also try to derive the third equation of motion. We will try to understand the third equation of motion. So let us see. In the last class, we had done a formula for average velocity. If you remember, we had written the average velocity is given by the formula V plus U by T, V plus U by 2, and average velocity is also given by the formula total displacement by total time. These are the two formulas of average velocity. We can equate these two expressions and get displacement by time is equal to V plus U by 2. Okay. Now, this was the same thing we did for to derive the second equation of motion. Now we can use here, we can put transpose this T. So we will be writing S equals V plus U by 2 multiply with this multiplied with T. So the same expression we had obtained, in the previous example. That means for the second equation also, we had obtained the same thing. Now we just have to bring in the last one, in the second, to derive the second equation, we substituted the value of V from the first equation of motion. So here we observe from the first equation of motion, we have V equals U plus AT, or we know acceleration is given by V minus U by T. So we can obtain the value of time. By transposing time, we can get here the value of time. This implies that the time will be equal to V minus U over A. Everyone getting what have we done? This is the formula of
Yes, sir.
acceleration, where we know acceleration is equals to V minus U by T. And here we have put T, transpose this T to the other side and bring A to the this side to the right hand side. You get time equals to V minus U by E. So using this value of time, we can use this value of time in the third equation of motion. Here if we utilize this value, we can write, all of you keep your camera on, turn on your camera, all of you. So we can put this S equals to V plus U by 2, V plus U by 2 multiply with T, and the value of T we write here as V minus U by E. So this is the value of T which we get here, and we have used this value. Any doubt how this comes? The value of T. The value of T we obtained from the first equation of motion, or we obtained it from the formula of acceleration. You can see from the formula of acceleration, we obtained the value of time period, or time. The time is given by V minus U over A. So you can multiply the numerator and denominator. You will be getting here S equals, see, you have V plus U multiplied with V minus U. So this is the formula of A plus B multiply A minus B. What answer should we get here?
A square minus B square, which is V square minus U square.
Yeah, so we'll get here V square minus U square divided over 2. Now, how can we get this third equation of motion?
One can transpose 2A to the
Yes,
left hand side.
trans transpose this 2A to the left hand side. We will get here 2AS equals V squared minus U squared. So in this way, we get the third equation of motion. V square minus U square equals 2AS. This is the third equation of motion. And you can see in the third equation of motion, there is no variable as time. You do not have time anywhere. There is no time. So to find out the displacement, you need not necessarily know time. Even if you don't know time, you can find out the displacement using initial velocity, final velocity, and acceleration. Okay. So again, uh, I make a list of all these equations of motion here. So we have the first equation of motion as V equals U plus AT. The second equation of motion we have S equals UT plus 1 over 2 AT square. Then we have third equation as V square minus U square equal to AS. So in this way, we have all the three equations of motion. Now, depending on the variables which we know in the question, so it's not necessary we know everything. So whatever is given in the question, accordingly, we will apply the equation. Whatever equation can be applied, we can apply them. You can see we have a total of 5 variables, but each equation consists of 4 variables only. Okay. So if you know any of the 3 variables, you can give or you can answer the fourth variable. Okay. You can find the rest 2 variables if you know any of the 3 variables. Okay. So has everyone made a note of all these 3 equations of motion?
Yes.
Pranav, Yukta, can you turn on your camera? Everyone, please turn on your camera. Okay. Okay, here. Now, Pranav, Janvi, yeah, fine. So now I will give you a few questions and we will try to solve them using these equations of motion. So let's, Okay. So let's see. Let's try to solve these questions. So let's see. We start with this question 2. So these questions, your question 2, a bus decreases its speed from 80 kilometer per hour to 60 kilometer per hour in 5 seconds. Find the acceleration of the bus. Okay. So what all information we are given in this equation, in this question?
Sir, initial
Initial
velocity,
velocity.
final velocity, and time.
Okay. So we represent our initial velocity u, 80 kilometer per hour. Then we are given the final velocity v, which is 60 kilometer per hour. We are given time as 5 minutes. So t is equal to 5 minutes. This is 5 seconds. So t is 5 seconds. Now we need to convert this 80 kilometer per hour to meter per second. So this would be 80 multiply 5 over 18. I hope you know how to convert kilometer per hour to meter per second. So find out the answer. I'm waiting for 1 minute and then I'll tell you the answer. So see, it would be 80 multiply 5 over 18. Now you can keep checking your answers.
Sir, 2.8 meter per second square.
Okay, let's check it out. 60 multiply 5 over 18. And we can find out here acceleration as v minus u by t. So v is final velocity 150 over 9. However, if you simplify, you will be getting something else. Okay, even if you simplify this, you will be getting some simple answers over here. Okay, but I have not simplified it. If you simplify, you will get 50 by 3. Okay, so here you can get 50 by 3, but I have kept it for some reason. So you get here 1 by 50, 1 or 150 by 9 minus 200 over 9 and divided by 5. So this is what is acceleration. We get here minus 50 over 9 divided by 5. So it becomes 10. You get here minus 10 by 9. So is that your answer? Minus of 1.1 meter per second square. Yes? Anyone has got this answer? Minus of 1.1 meter per second square. Rohit, Sampath, anyone got this answer?
No, sir.
No. Okay, so now you understood this question. Where
Yes,
did
sir.
you go wrong? Did you look up where did you go wrong? See, even if you convert it to decimal, then also you will get the same thing. Okay. But the only thing is that your calculations will increase. Your calculations will increase. Okay, so try to find the next one. Try to find this answer to this third one. A train starting from a railway station and moving with uniform acceleration attains a speed of 40 km per hour in 10 minutes. Find its acceleration. So I prefer you to find the acceleration in fractions only. It will be in meter per second square, but in fractions. Okay. So let's see if you can find this out. This was your solution to question 2. You need to solve this third one now.
Sir, I'm
And
getting.
whoever solves it out, please send your answer as a direct message. Okay. So anyone who got the answer?
Sir, I got it in bar.
You got it in?
Will I send it to you?
Sir, I got
Yeah, I have got here two answers. One of the answer I got from Harshit. One I got from Sampath. And Rohit has also sent the answer. Okay, so let's try to solve this out. For this, what is the value of initial velocity? What is the initial velocity given to
So
us?
it will be 100 by 9.
0.
Okay, what's the initial velocity?
So for
0.
0, 0, 0.
0. So here your initial velocity is 0. U equals 0
So
meter per
and
second.
V is 100 by 9 meters per second.
Where? For the second one.
So third one.
Okay, let's check it out. So initial velocity 0. We get the final velocity as 40 kilometer per hour, and we convert this as 40 multiply 5 over 18. So we multiply this by 5 over 18 to convert it to meter per second. So we convert it to meter per second by multiplying it by 5 by 18,
100 by
and
9.
hence
Then 100 by 9.
Yeah, we get here 100 by 9. Now, the acceleration will be given by v minus u over t. But what's the value of time here?
Sir,
600.
How
600
much
seconds.
time? 600 seconds. You will be taking everything in SI system of units. So it would be 600 seconds. Now, we get the acceleration as v minus u over t. So that is 100 by 9. 100 by 9 minus 0 divided by 600. So by simplifying, we get here 100 by 9 multiply 600. And hence you can cancel these zeros. You get 1 by 54. Your answer is 1 by 54 meter per second square. So how many of you got the answer 1 by 54?
Sir, I just
Sir,
made a
I
small
got.
error, but sir, I made a small error in the last step. That's why I got a wrong answer.
Okay,
Sir, I got
Sampath,
1 by
Sampath has
54.
given. I think Sampath has given the right answer.
Yes, sir.
Okay, I got Sampath's answer to be right. Rohit somewhere went wrong.
Sir, in the
Harshit also.
last steps, I made an error. That's why.
Okay. So try not to do any mistakes.
Yes, sir.
Yukta, what happened? Are you getting how to solve it out?
Yes, sir. Actually, I did one part wrong because of which I got the wrong answer.
Okay. So try not to do the same mistakes in the coming questions. Okay. We'll
Yes.
be doing here a number of questions so that you can practice all the equations. Let's see the next one. Okay. So let's see this question. So you have a train starting from rest, attains a velocity of 72 kilometers per hour, and in 5 minutes, assuming that the acceleration is uniform, you have to find the acceleration and second, the distance traveled by the train. So let us refine all the information that's given to us. Since the train starts from rest, we take the initial velocity as 0. The final velocity attained V is 72 kilometers per hour. This is 72 kilometers per hour. And time is 5 minutes. And what all we have to find, write that also. For example, here we are supposed to find acceleration. So write here A, acceleration we want to find. We also find out the displacement, that the distance traveled, which will actually be equal to displacement. So these are the two quantities which we need to find. Now for that, there are two conversions which we need to make. We need to convert this 72 kilometer per hour to meter per second. And if you convert this, you will be getting 20 meter per second. This is the answer that you will be getting. Check out your answer. You should be getting 20 meter per second.
Yes, sir.
Yes, sir. And the acceleration also I got.
Yes.
So
And
the
the time would be 300 seconds.
300 seconds.
Okay. So
so the
here time would
acceleration
be
is 2 by 30 meter per second square.
okay. So time is here 300 seconds. And we get acceleration here. So we can find out acceleration as v minus u by t. V is 20 minus 0.
Sir, A will be 1 by 15 meters per second.
Okay, so for this,
Sir, acceleration will be 1 by 15 meters per second square.
okay,
So,
acceleration we will get here 1 by 15 meter per second square. Now we can find out the distance traveled. We have to then our next target is we want to find the distance or displacement. So which equation of motion shall we use?
Sir, second.
for the second
Yeah.
one.
We can use the second equation also, and we can use the third one also. From both of them, we'll get the same answers. So we'll use S equals UT plus 1 by 2 AT squared. And by injecting the values, by putting the values at proper places, we now just need to put the values. So we will get
Sir,
here
we'll get
S equals,
3000 meters.
okay. So S equal, we get 0 initial velocity multiplied by time, which is 300 multiply plus 1 by 2 multiply acceleration, that's 1 by 15, and multiply 300 squared. It's 300 squared. So now see, here your calculation is very important. How do you calculate? 0 multiply 300 would be 0. So we get here 0 plus 1 by 30 multiply 300 multiply 300. So do not cancel it before making the square. First make the square and then cancel. Okay. So remember, solve the
But
bracket
it's
first.
300.
Yeah, how much it is?
So
It's
300.
3000.
Oh.
It's not 300. We are
So,
getting
but
here.
what if we square the number?
Okay, sorry, it's 900. 9000.
Yes, sir.
Sir, it's
It's
3000
9,000.
because the denominator is 30. Sir.
Sir,
Okay,
3000
okay, it's
only, no,
30.
sir.
Sorry, sorry. Okay, sorry. I got it. I got 300 here. It's 30. Okay. Time is given as 30 here. So we put it 30 squared, and hence you will be getting 900 meters. It's correct now? You get 900 meters.
Sir, time will be
Sir, it's
300 only, no,
3000.
sir.
Sir, in the time will change,
Sir,
right?
3000 will get, sir, because it will be cancelled by 30, we'll get 3000 only, because 300 if we get, we'll get 3000 only, sir.
Okay, so 900, and here 0 and 0 cancel, and it's so how much? 90 meter?
Sir, the seconds are
So,
3000 seconds, not 300 seconds.
okay, so is it correct now?
Sir, you wrote one, sir, in the first equation, S is equals
Time
to
is
0
3000.
into 300. Ah, sir,
Okay,
time
so
is 300.
this one you are talking.
Yes, sir, time is 3000.
Yeah, sir.
Time is 3000 or 300. Or is
No,
it?
300.
sir, 300. 5 into 6 is
Okay, okay.
300.
All of you are making me confused. Just 1 minute. I just believed all of you people. So see here,
Sir, so
y- your
300.
time is 300, right? 60 multiply 5, that's 300 second. Okay, so put the value here, S equals to UT plus 1 by 2 AT squared. And you get here 0 multiply 300 plus you get 1 by 2 multiply acceleration, which is 1 by 15. Multiply, you have 300 squared, right? The 300 squared, you will get here 1 by 30. Multiply with 300, multiply 300. That's the square of 300. Okay. So you get 1 0 gets cancelled. This 3 cancels with this 30, you get 10. And you get here
3000
3000
meters.
meter. And 3000 meter is nothing but 3 kilometer, right?
Yes, sir.
So anyone got this answer now?
Yes, sir, I got.
Yeah, sir.
Anyone else? Yukta, what happened now?
Nothing, sir.
See, maybe you are not getting right now, but just understand the steps and you will be able to get the subsequent questions. Okay. Jitendra, are you getting? Yes, Jitendra, are you getting?
Yes, sir.
Okay, where are you? I can't see you. Your head is down. Okay, this is your helmet. I can just see your helmet. Okay. Okay, now I can see. So now I will give you next question as a complete try. I will not be solving it out. I will wait for 3 minutes then. Okay, I give waiting time to 3 minutes, and let's say you should be able to solve this question. So a similar question here. So this one we got the answer. Now this, a car accelerate uniformly. This question. You see? Okay, I give you 3 minutes to solve this problem. Do your calculations, everything. कितना है? कितना है? एक मूवी भी दे दो फिर आधा दे दो In the meanwhile, you can check whatever you have calculated.
Sir, answer.
So you should be checking, you can check your answers. You should have got these values.
So should we post the answer in the chat?
Hmm?
Sir, should we post the answer in the chat?
Close the answer in the chat.
Yeah, sir.
You resend your answers. That will get.
Sir, I got the same answer, but I'm unable to send to you, sir.
Okay, so send it. I'm waiting for the distance. Let us see how many of you are able to calculate the distance.
Sir,
That is
should I say the
S.
distance?
Yeah.
Sir, is it right?
Okay, see your displacement. Just wait. I'm waiting for others' answers also.
Should I send the answer to you?
Okay.
Sir, even me.
Okay. So okay, some of you have sent the answers, but they seem to be incorrect here. Let's see, so a few of them are incorrect. So from 18 kilometer per hour, you have your 5 multiply t, that's 5. plus 1 by 2 multiply AT squared. So here there are two answers which are correct. I got Sampath answer and Akshara's answer. They are correct. Okay. Others can check. Sampath and Akshara, their answers are correct.
Sir, how is acceleration 1 meter per second?
Hmm?
Oh, nothing, sir.
So put here 1 multiply t squared, which is 5 squared. So you will get here 25 plus 1 by 2 multiply 25. And hence you get here 25 plus 12.5. And this should come out to be 37.5 meter.
Yes, sir.
Okay. Yeah, Yukta also got this time correct. She has also given the correct answer.
Sir,
She
even
has
if we leave
also
the
given correct answer.
sir, even if we leave
Hmm.
the distance in fractions is also correct.
Yeah, then also it is correct. And Muhammad Ryan, Janvi, I have not got your answers. Okay. So please practice some more questions
Yes, sir.
to clarify your doubts. Okay. And you will be having in this week, you will have a test from these topics.
Yes, sir.
Okay. Okay. Bye everyone. Good night.
Sir, I had
Bye,
a
sir.
doubt.
Thank you, sir.
Yeah.
Sir, the third equation of
Hmm.
motion is used frequently, right? In most of the questions.
It depends on the problem that is given. Okay. It depends on the problem. Okay, bye.